about the midterm.
No, Daddy, no, I don't want to play.
Right, we're having the midterm right now.
You got a piece of
That would remove all the stress, right? Didn't even know you were coming. It was a pop.
Let's just put all the stress in at one time.
It's a pop midterm.
I
Shut up! All right. So midterm is going to be the Thursday when we come back from break. So 9 days from today, week from Thursday. So we'll review on Tuesday when we come back from break, go over kind of what to expect in terms of content on the midterm. It will cover everything we've talked about up to this point. I'll go through our slides and our interpreter and kind of tell you what things I think are fairly important, what things I think are not necessarily as important. Quizzes should indicate fairly concepts that I deem to be fairly important. So think about the quizzes that we've taken. If you go on to Blackboard, every quiz has the question that was associated with it. So even when you get zeros on it because you didn't show up to class, you still can see what the question was and whether or not you could have answered it. But you get a free 30 points for being there. The difference between somebody who doesn't attend and somebody who attends and just puts a question mark on the quiz is 30%. That's legit.
Or 100 points if question mark is the answer.
Or 100 points if question mark is the answer.
For all else fails, throw out good.
Bring Jesus down. You gotta get some points. Yeah, that's a point.
So, hey, we can reverse engineer that. Give me an example of a question where question mark is the answer.
This is not Jeopardy.
That's appropriate for this course.
An operator for something.
What is the extra keyword onto an equal sign that compares it? How do you indicate a predicate?
Ah,
There we go, yeah.
How do you indicate a predicate? Predicates, naming conventions typically end with a question mark. Number, question mark, that kind of thing. Okay. So, shut up! Third time I start throwing desks. All right. So the exam is I'm going to design it to take about an hour. You'll have the full time, the full period to take it. In here, the exam is going to be largely, it's probably going to be a minimum of half programming, but it's hard to ask any questions in here without some programming aspects. So there'll be several questions that deal more with the theory things, like I might ask you a question to write a Lambda calculus expression that meets some constraint or something like that, where a variable occurs both free and bound, that kind of stuff. Okay, and then I'll also have you write some procedures as well. So expect to have to write functions that do stuff. So if you can't write anything in Scheme, the exam is going to be tough.
How are your cats doing?
They're going well, actually. Yeah.
I mean, I'm just recalling these exams.
So I think your max score, if you suck at programming on this exam, is probably going to be about a 50. That's max score. So a little bit more programming intensive than maybe some other exams have been, because this is called programming languages. It's kind of a thing. And let's see, the exam's worth 20% of your grade, right?
I thought it was 50.
No, I think so, and I have my usual policy where if you bomb the midterm, then come back and do better on the final, I'll replace your midterm grade with what you get on the final, but not the other way around. So you don't get to ace the midterm and then get a 0 in the final and get the midterm grade for your final. It's only if you show improvement, not show that you're more stupid. Most stupidest. ish. Which. All right. So that's the generalistic thing. So this is Thursday after break.
I'm gonna be on Vicodin.
All right. So let's go back and keep looking at our interpreter so I can give you your crazy assignment over break. Okay. So last time we were starting to work on our run program, and we did expand our environment to support us storing functions, right? Now, why is it that we did not evaluate Lambda expressions? So our either second or third production, depending on which version of it.
There's nothing to evaluate because you don't have values for the parameters.
Yep, it's not evaluable.
Yes, that's the word.
It's not. That's a bad word.
Evaluatable.
Evaluatable sounds more correct.
You're on.
Okay, but in any case, a Lambda expression in and of itself doesn't make any sense. We can't evaluate it to anything. All right. So in order to evaluate a Lambda expression, we must have an app. It must be embedded within an app expression. All right. So when we added our Lambda expressions to our environment, we associated a variable name with them, and then we added them in an unparsed form into our. Actually, no, we added it in a parsed form but unevaluated form to our environment. Okay. So I think at the end here we showed this thing. We haven't quite written our ability to apply something to something else. Yeah, so I think this currently breaks, right? Yeah, and that's in our, was that an eval expression? Under app expression. Yeah, so that we're okay there. So let's kind of trace through this. Because as of right now, I think we can do things like so can't we do a?
That's the section that was given.
Well, we can do a lambda AB and do 1, 2 like that, and this should print out a 2, correct? And then we can do an A instead of the B, and we should get the 1. All right, so we support having the first part of our app expression expecting more than one parameter. So we have the ability to pass in a list of parameters to this guy. So this creates an environment where A is equal to 1, B is equal to 2, and then we evaluate the body in that. But what we'd like to do next is have something like this, which I just had written before. This guy, where this lambda comes in for A. So A is equal to this function. B is equal to 5. And then the body of this guy applies A to B, which should just give us a 5. Does that make sense? So this isn't what's working. This does not quite work yet. So let's trace through this and see kind of what's going down and why it's breaking. And it's because we're in this else down here. We don't know how to handle something where it doesn't start with a lambda, I think was our problem. So I'm going to go ahead and run this so we can at least get how this guy is organized. And I'm going to steal this. And we're going to bring this over to our presentation guy. Go ahead and create a text box. Left justify this. Paste that in. And then let's shrink it down. Okay. So right now, that is what our thing parses to, right? All right, so our last app expression, this guy here, is something that takes in 2 parameters, and then the body is a list containing our lambda expression that takes in 1 parameter, whose body is the list, which is a var expression. and our literal expression 5. Okay? So we want to walk through it and see how our code deals with this. This is our parsed version. All right, so the very first thing we do is we are calling, let me just scroll up here. So we're calling run program, passing it the parsed version of our expression. Here's run program. What does run program do? It just calls eval expression, passing it an initial empty environment. So run program is just a wrapper for building an empty environment and calling eval expression on that. Okay? So at the end of the day, we're coming into our eval expression up here. And what do I need to do to get that stuff going away like that? There we go. Okay, so we're bringing in our lambda calculus expression and our environment, and we are dealing with something whose car is app expression, right? So the car is not lit, car is not var, car is not lambda. The car must be an else, which is in this case an app expression. So that's the kind of animal we're dealing with right here. All right, so now this says if the list ref at bucket 1, which is going to be this guy right here, right? And then we're going to get bucket 0 of that, which is going to be this guy right here. If that guy is a lambda, then we're going to do some stuff, right? And in this case, is it a lambda? Yep, so this is list ref bucket 0 of bucket 1. That's what this guy is. This is bucket 0 of bucket 0. This is bucket 0 of bucket 1. Right there is our lambda expression. So since it is a lambda, what are we going to do? We're going to call eval expression on. Again, we need list ref at bucket 1. And then we're going to get bucket 2 of that guy, which is going to be the body of this lambda expression. This is bucket 0. This is bucket 1. Here is the body of that guy. Right there. All right, so what I have highlighted there is this part of the code right here. Eval expression, list ref LCE1, 2, passing it the extend env for lambda, giving it our, all right, so we're evaluating that expression. Let me just copy this, just so we have this guy. So I'm going to kick us down to another screen. So this is our second call to eval expression. First call to eval expression is this guy. Second call to eval expression is calling on this guy. Okay, but it's calling eval expression on this with an extended environment. We're going to write that extended environment here. So this is our second call to eval expression. All right, so originally we had an empty environment. So this guy's environment, env, was the empty env. So no environment for this guy. But this guy, our second page, has an extended environment. And that happens right here in our code. Extend env for lambda, where we're going to pass it bucket 1 of bucket 1 as a list, which is going to be this guy right here. We're expecting sets. This is bucket 1, and this is bucket 1 of bucket 1. So that's our list of variable names that we're taking in, right? Okay. And then we're calling, so that's the first parameter to our extend env. The second parameter to this guy is going to be what? It's going to be mapping this function, that is lambda x, so a function that takes one parameter, across every element of, let's see, that guy ends there. That guy ends there. So we're mapping it across every element of the CADDR of LCE, which actually is not very compatible with what we're doing here. We really want to switch this up. I think it's correct how it's written. We probably want to do it list ref 1-2 instead of CADDR. That is, give me the body of the app expression. So this is list ref 1, 2, which is the values being passed into that app expression. Let's go back and let me explain that to you. This right here is bucket 1, right? Of my entire expression, LCE, that's bucket 1 that I have highlighted. Okay? So that's every single time that I say this right here, I'm just talking about that piece. So that's talking about that piece, that's talking about that piece, that's talking about that piece. Then we're grabbing different values from that. Okay? So what are the various values in that? So within this guy, this is bucket 0, this is bucket 1, this is bucket 2. So bucket 2 of this guy is eval expression. I'm mapping eval expression across. Yeah, across this whole thing. All the way up to that. Right? So I'm mapping it across that guy right there. And what happens when I map eval expression, or what happens when I map this function across that? How many parameters are coming in from this guy? How many things are in this? Just one. The body of the first app expression is one thing, another app expression. All right, so if we were to kind of generically write this guy right here, let's copy this and create a secondary slide that kind of shows this. So we have a list that is, so if we were to kind of rewrite this, okay, so we're going to say we have an app expression, and this app expression is applying a lambda to an app expression. That second app expression, I guess I didn't do the, that second app expression is applying, what's this guy right here, a lambda to, actually it's applying a, so the body of this is, yeah, it's applying a lambda to a literal 5. In that case, actually, hold on, it's not. This app expression here takes in 2 parameters, an A and a B, but that doesn't look like it's written right there. That's not parsing correctly?
Not parsing correctly.
The first question is it written incorrectly? Not our code, but our function. So we have a lambda that takes in 2 parameters, A and B. It doesn't know how to deal with this. We haven't defined something that looks like that before. So that's going to come into our app expression here in this else. it's not going to be a lambda. So it's not going to be this first guy. So this is the if, right?
That's the, that thing is true.
Yeah, so if it's a lambda, do that. Otherwise, do this. So in this case, we would be inside the otherwise for eval expression. All right, but it appears like the issue here is that our parsed code doesn't look correct. So app expression, this should say list A and then this should say list var expression A and list var expression B. Correct? For the parameter list of that. Well, no.
Shouldn't it be?
There should be a list containing a list var expression A and a list var expression B. So this whole thing here should be inside of a list. So the problem has to be inside of our parse. Well, our starting problem has to be inside of parse. So what happens if we send something that looks like this? Let's simplify our code here. Becca? Semicolon? All right, so let's do this, and I'm going to steal this line real quick, and then let's comment that out. Let's put this in there. All I want to do here is let's just get that piece parsed correctly. So this is a lambda that has two parameters whose body is an app expression, right? Formatted in the correct way. So this is the guy that's not going to show up correctly right now. Yeah. This guy, he's correctly being defined as an app expression, but we're not building that list of things. So this should be an app expression applied to just A and B. Those are the parameters, right? A applied to B. All right. So let's go back to our parse. So parse expression. We're going to be passing in a lambda calculus expression, and this guy's going to look like this. Okay, so we're passing in something that looks like that to that guy. So we're going to trace through this in parse expression. In fact, let me just copy this and bring it up top here to where parse expression is. All right, so we're going to come in and we're going to ask, is this guy a number? Actually, we're just going to get in here, right? So is our lambda calculus expression a number? It's not. Is it a symbol? It's not. Otherwise, is the car of this guy the word lambda? It is. So the car of that guy is lambda, so we're going to get in here. What are we going to do? We're going to create a list containing the word lambda expression, followed by, yeah, so this is where we run into our issue. We really need to map parse expression across the rest, right? So we have, oh no, this is the what's presumed to be the lambda expression. Yeah, so a list containing this guy, which would be the car of the cooter. So that's this piece right here. That's the car of the cooter. So that is our app expression.
No. That's your parameter.
Yeah, so the
expression is the next one.
yeah. But this is the car. The car of the cooter will be this guy.
Yeah.
Oh. Lambda expression followed by parameter list.
Yeah.
So that's correct. So that's just our parameter list for this guy. And then the body is going to be this guy. And what are we doing with this? We're calling parse expression on the body, just this part. Right? All right. So yeah, here this is the issue. So this is going to get us down into this else. So now we're running into something that looks like this. We just call parse expression. It's not a number. It's not a symbol. Its car is not the word lambda. Therefore, we do this else thing where we say it's create a list whose first element is app expression and whose rest is parse expression on the individual pieces, where really this should be the map of it. We want to map parse expression across this entire list. Correct? Can you make us a list? So let's actually take parse expression off of that. That was back when we were assuming that first guy was actually a lambda, not potentially a variable that holds a lambda. Okay, so this was our old version of parse. So we're going to make a list out of our app expression, followed by mapping. And remember, an app expression is going to have a single value followed by another value. Let's think about this. Let me back up here for a second. Yeah, really, the issue here is these guys should, map always returns a list. We want these to be appended. So I think we can just do this. Append whatever parse expression returns for that to, let's throw another one in there, that guy. That should glue those two lists together, giving us a flat list. No, it's not either. So this should just say app expression, then var expression A, and then var expression B. So we really need to flatten this. Okay. We have to use our appends in the correct way. So we are going to have the where am I at here?
Did that one not return the list?
It did. It just the wrong list. Okay, so we're going to create a list out of app expression. So now we have a list containing app expression, right? We're going to take that list and we're going to append it onto. I'm going to take the append off of this. Actually, hold on.
Would you create that as a list, though?
I don't think we want that as a list. We want this as a cons. So we're going to cons. No, we're in the right place. Just I had extra parentheses. So we're going to cons this guy onto the list returned by appending this guy, which in our example here is going to be the list containing var expression A, right? That's what this will boil down to. That will be the list containing var expression A. That guy. We're going to append that list. Oh. This guy should be a list. So we're going to create a list of this with I. Let's draw this. So this is going to give us a guy that looks like this. We're currently consing app expression onto what we're going to be getting for that next piece is this. Var expression A. That's what ultimately is going to be boiling down for that second piece. So var expression A is going to be what's returned by this guy right there. Okay, forget about the conses and stuff right now. And then this guy right here is going to produce for us a list containing a var expression b, like that. So we want to take these three pieces. So let's take the cons off there. These three pieces, 1, 2, 3, and ultimately produce a list containing app expression, var expression A, var expression B. Like that, right? That's what we ultimately want. So how do we take these two pieces here and glue them together so that we're left with a list containing just this guy? So how do I take these two lines and produce the list?
Var expression A as a list, append that to var expression B.
Var expression A is a list. Oh, you got to wrap it. You want to wrap this guy first. So you're going to say, we're going to take this guy, wrap him in a list, then append him onto this guy. Okay, so you want to do, so this is going to be an append. This is going to be the list version of something that we already know is a list, right? So what we just did there, what's kind of highlighted, is this piece right here. We took this guy and we wrapped him in a list. Then we're going to append him onto whatever's returned by map here. So we're appending him onto map. So that guy right there should return for us the appended version of these two guys glued together, which should give us the list containing var exp A and var exp B. Like that, right? And then we want to cons this guy onto that list. Right? So cons that guy onto that list. All right, let's see how that looks. Yep, app expression, here's A, here's B. All right, so that looks like it's parsing the correct way now. All right, so we had to make our parse compatible with, it wasn't that our parse was broken from a long time ago, it was that we've changed our language to now support more than one parameter being passed in for app expressions. And parse didn't handle that, or our parse expression hadn't been upgraded to handle that. All right, so now,
You have to change unparse now.
well, technically yes, but we're not using unparse right now. So, isn't that true? We're not using it anywhere. But yes, if we intend for unparse to work, we do need to do that. All right, so now we're stuck with that. Let's just make sure this guy parses down correctly. So we have our app expression, whose first element is a lambda expression that takes an A and a B, and its body is going to be an app expression, this guy. So this is a lambda expression who takes in an A and a B, whose body is an app expression, who takes in an A let me read this real quick. Here's our outer app expression, whose operator is a lambda expression that takes in an AB, and whose body is an app expression that takes in a and B. So here's the operator, here's the operand for that app expression. So that's this guy right here. That app expression, when parsed, turns into this guy right here. an app expression whose operator is the var expression A and whose operand is the var expression B. With the understanding that since this is a var expression, we're going to be looking this up in our environment, hopefully pulling out a lambda expression. Because ultimately, app expressions only work if we have a lambda expression. Okay? So this isn't incorrect, but we need to make sure our variable environment supports resolving functions. Otherwise, we won't be able to pull this guy out. Okay? So that is the operator part of this. So our operator of our app expression is that guy. Okay? Then the operands of our app expression, the first operand is this guy. That is a lambda expression that takes in a single parameter list, a list that contains a single parameter, whose body is just a var expression x. And the second operand is lit expression 5. Okay? So what should ultimately happen here when we run this? Well, whenever we have a app expression, a brand new environment is generated, right? All right, so here is the operator of our original app expression, and we need to take these guys, the parameters A and B, and this is where we call extend-env for lambda. We're going to pass in A and B, and then the values lambda x and 5 for these two variables and store them. All right, so they'll get stored. Then we will execute the body of this guy in that extended environment. So let's go back here. Let's update. Now that we have correctly parsed code. This is our first call here. Okay, so and this all happened inside of the empty env, correct? The second call, that is when we called eval expression on whatever variable A boiled down to, we had to resolve that guy. And that's okay because what do we do here? Let's come into our code, go up to eval expression. Let me press something here. Just so I don't forget. Let me take that extra comment out of here from our before parse expression. All right, so we're calling eval expression on the body here, which is this guy. Okay, that's the body of our original app expression, right? So we're calling eval expression on that body with the extended environment created using this guy and these values. And that's what happens right here. So we're calling eval expression on bucket 1, 2. That's the body of that guy. So bucket 1, 2 is this guy right here. That guy. Okay? So that's the body of our original Lambda that we are executing inside the extended environment with bucket 1, 1 and mapping eval expression over the rest. Extend env for Lambda with bucket 1, 1 and mapping eval expression given the current environment that we're in. So for both of those, it'll be the empty environment, right? Across bucket 1, 2, which is going to be those guys. So what's that going to ultimately give us? That's going to give us an expanded environment that's going to look like this. So inside of this, that's our first call. Oh, Let me steal this. I forgot we had a second screen there. So this is our first call in an empty environment. Here's our second call. And our second call is actually just happening here. It is actually calling just that guy, right? So now we're evaluating this expression, an app expression, whose operator is A and whose operand is B, inside of an environment, but it's no longer the empty environment. Now it's the environment that has two values in it. So we should have A, let's just kind of keep this like in a simple little format for us. A is equal to a lambda, and B is equal to 5. That make sense? So this is the result. This environment down here is the result of calling extend-env for lambda, passing it our function for A, that is this function right here, that guy, and passing it our literal 5 for B. So that's what we wrote last time, so we can extend that environment. All right, so now we're evaluating this app expression in this environment. So how do we evaluate this app expression inside of this environment? Well, let's go back down to our app expression. So we're going to go through all of our, is it a number, is it a symbol, is it a lambda? Nope, this guy's car is an app expression. That's this piece right here. So else, we must be in an app expression. But now his car is going to be a lambda, but his car is not currently a lambda. So what do we do now? We call eval expression on the eval expression of the first guy, right? List ref LCE1. That's going to be this. We're calling eval expression on that guy. And what will that guy boil down to? That lambda. We're going to resolve that lambda. And eval expression on 2. So we're extending our environment, passing it. Oh, see, this guy makes what assumption? So this part right here is going to resolve our function right there. And we can prove that by just taking off some stuff here. Well, we'll see it here in a second. So that's going to resolve to the lambda that we had stored with A in our environment. env in this case is this env, this guy here. That's been extended with those couple of values. All right, so the hope is that this guy boils down to that environment, and it should, or for that function, and it should, because how do we get, when we see a var expression, what do? We call apply-env, passing it that guy. And he yanks out the value associated with that. And in this case, the value associated with A is our lambda. And then we're going to try to extend that environment, passing it the parameter list here, which now becomes a problem, right? We don't have a parameter list for this guy. So extend env, this guy's expecting a parameter list, but we don't know that that guy is a lambda yet. In this case, it will be. So when I say list ref 1, that guy, he's coming out as a var expression. He looks like this right now. That is that list ref 1. He looks like that. Now, when I say extend env for lambda, list ref 1 of that guy, that's going to just give me the letter A. But that's not really what I want to be working with here. I actually want to be working with this parameter list here. That make sense? I want it to resolve A first and then extract the parameter list associated with A so that I can actually extend my environment. Right now it's not doing that. Right now I am evaluating my expression here. That is going to give me that lambda. So what that's going to ultimately boil down to, what I have highlighted there, it's ultimately going to boil down to this guy right here. Which is correct. That's what he should boil down to, right? But since eval expression always assumes we have a lambda in the far left, even after I evaluate that lambda, so we deal with the lambda here if it's already evaluated. That's what this says, right? If my list ref 10 already has lambda exp on it, it's already been either resolved from its variable or it was a lambda to begin with. It wasn't stored in a variable. Okay? So, what do I do here? If I'm here, that means I did not have a natural lambda sitting there. In our case here, what did I have? I had something that looked like this. That will become a lambda, but isn't a lambda yet. It's only going to be a lambda after I apply it in the environment, which for us is after I call eval-exp on that guy. Okay? So, ultimately, we get the right thing from the code that's highlighted there. That guy will get us that lambda expression that we should have. Okay? But now, once I have that lambda expression, I need to extend our environment here with something from that lambda expression. But I'm not doing that right now. I'm instead working with LCE, the unevaluated variable. I want this piece. What I'm grabbing is this right here. This piece here is found upon evaluating this piece right here. So I need to store that evaluated value somewhere. Make sense? And when you need to store something temporarily in our programs, what do? What do we have to allow us to create a local environment inside of Scheme? A let, right? So what we need is we need to go ahead and get the answer to this guy. We need to take whatever that expression boils down to and store it somewhere. Okay? So what I'm going to do here is we're going to go above this guy. We're going to create a let, and we're going to say let evaluated exp, and actually this guy is 2 parentheses. We want that guy to be equal to whatever's returned by that function right there. Okay? So I've created a little local environment here, and in this local environment I'll have a variable, and this variable, that is the evaluated expression. Okay, or if it makes you feel better, maybe we call it this. Resolved var. So in our world right now, this is A that's been resolved to the lambda that it pointed to, the lambda that it held. All right, so we're going to go ahead and resolve A here, stored inside of a variable called resolved var. Its value is going to be whatever gets returned by eval expression on that stuff. And since it was a var expression, it's ultimately going to be the apply-env thing up here. So we're in this let. Now we're in the body of the let right here. And what do we want to do in the body of the let? We want to evaluate the expression. What expression? The resolved var expression. That's the guy we're evaluating inside of the environment expanded using what? resolved var. So get me bucket 1 from resolved var. Actually, let's think about that. Resolved var is going to look like just this guy, right? So I actually just want list ref 1 of that.
I'm just
All right. So, because I've already resolved it, that var expression A, this guy right here, will ultimately turn into this. That's what just came back. Okay? That's what's currently stored in resolved var. What I have highlighted right there. After it's been resolved, it'll look like that. So I need to extend my environment with this part, which is list ref 1 of that guy, right? So it's not list ref of list ref, it's just list ref 1. So that'll get me my variable values. And I want to map that across what? The list that is the rest of this guy. So we potentially could have multiple things there. So really what we need is this is the, probably want to use cars and cooters for this guy. So if we say the cooter, we have to list this guy. We say the cooter again, we have to list this guy. So it's the, that's the list containing all those elements. Right? Cooter of this guy gives us the list containing these 2 elements. The cooter of that guy gives me the list containing, in this case, that 1 element. So it's the CDDR. Will give me the list of all of the operands. So I'm going to be mapping this function, that is eval expression, within the current environment across CDDR of resolved var. That'll give me the list of operands. So I'm going to map that onto this. And then I'm extending my environment, passing it this parameter list, passing it this list of resolved operands, and the environment I'm extending is env. So that should look like this. I'm going to evaluate the resolved var expression in that now extended environment, which should ultimately give me a final answer. That's all happening there inside of the let. That's the end of the let right there, which is the else of, is this guy a lambda expression? So for us right now, if we're looking at an app expression, it's either naturally a lambda, which means that it's a function directly being applied to its parameters, or it's a lambda that must be stored inside of a variable and must be resolved first. If it's naturally a lambda, deal with it here. If it's inside of a variable, resolve it, then use that resolved lambda to eval the expression in the environment extended by the parameter list of that resolved lambda, passing it the operands that came in. All right, and then one final closing parenthesis. We have an extra one because of our let that we added on here. Okay, so if this works, what should we have? This is our original operand in that app expression. We're applying that operand to these 2 operators. That is, this guy will come in for A. This guy, 5, will come in for B. So our environment will be extended with a function and a literal. Then we're going to evaluate the body, AB, on this. And when we get in there, we'll notice that this guy is an app expression, but he's our other form of an app expression. App expressions come in two forms right now. Form 1 is the guy that starts with a lambda. Form 2 is a guy that doesn't start with a lambda. And if it doesn't start with a lambda, we have to assume it's ultimately going to be a lambda, but we have to resolve it first. So we go ahead and we turn this A into this guy by resolving it, and then apply that guy to the value of B, which will be 5. So if I pass in 5 for x and then spit out the value of x, what should the output of this program be? If I'm applying just this lambda to this input, if I have a function that takes in a 5 and spits out whatever it took in, what's the output going to be? 5. So let's see where it's broken. All right, so this guy says how far in did we get?
Probably to after list AB, that list app expression is what I'm guessing is the issue.
All right, well, the first time through, we are definitely dealing with an app expression that is a lambda expression, right? So the first time through, we are getting into this if. This is a true statement. So what do we do if that's a true statement? We call a val expression on the body. That's this guy down here. So the body of that's the body of that app expression. So the body of that app expression is actually this other app expression. Right? So the whole thing, all the way down. So it's that whole second app expression. So we're going to evaluate the body of that first guy in the environment extended by setting our variable list, AB, that's this guy, to the functions returned by this guy where we're looking to see if something is a lambda. If it's a lambda, we're just going to keep it and not evaluate it. If it's not a lambda, so what I want to do here, if it's not a lambda, we're going to actually evaluate it and boil down to its whatever value it is. So in this case, we're going to keep the first parameter here, that guy, and we're not going to evaluate that. That's going to resolve down to just x. And then we're going to call the val expression on the second guy here, which was bar 5. Well, that's our lit expression, 5. So we'll evaluate that and it'll boil down to just 5. And so we're extending our environment. So that should give us the environment that has both of these guys added to it. All right. So we're going to need to check to see if apply environment allows us to get a function out of it. I suspect that might be where our issue currently is, that we need to upgrade that as well. All right, so that's the first time through. This is where our second call now is when we're calling eval expression on the body in that new extended environment. All right, so the body is just this guy, the app expression. That's the body right there. Okay? And it's being evaluated inside of the now extended environment that has our function and our 5 in it for A and B. So we're going to get down to the else. It's not something that starts with a lambda, okay, in our app expression, because this guy, this first thing here is a list. So we're going to get down to our else of this guy. So this is the else associated with this guy. So if it's not a lambda, it must need to be resolved. So we'll go ahead and resolve this guy. And resolving this guy is going to get us our lambda here. So ultimately produce this for us. Can we prove that? Let me see if I can prove that real quick. I'm just going to take all that off. And then I'm just going to boil down to resolved var. Let's just see that we got our lambda out of that. Oh, we broke before that. So it broke on the first time through. That is when we had an app expression. This guy, whose bucket 0 of bucket 1, this guy right here is lambda exp. So we called listref LCE 1, 2. So this is bucket 1, bucket 2. No, bucket 2. That's that second. That's the body. So we're evaluating the body in the extended environment. And which line was the error in? Okay, the error was in our extend env. So passing it 1, 1, which is the parameter list, and then mapping this function, lambda x, so the guy we're currently looking at is all right, so we're looking at a lambda there. So if the car of the thing is a lambda, just boil down to the x, but the car of that guy is lambda exp. So now my brain's in an infinite loop, and that's got to be bad. No wonder Nick was sleeping.
Most of the lectures.
All right, so I'm mapping, okay, I'm extending an environment. Here's the parameter list. That's good. So that's this guy right here. AB. Okay, now I'm mapping across this list. So that's the list containing these guys. So I have a list of those guys, right? Spacebar this. So I'm mapping that function across list ref. We're going to get bucket 1 of this guy, which is this whole thing. And then I'm getting, oh, wait a minute. There's got to be more out here. There better be more out here. Okay, yeah, there we go. Okay, so I'm getting bucket 1, 2. So this is bucket 1. This is 2. So that's where it's complaining it's an app expression. I don't want to map across that. I want to map across the values of the original app expression. Because my original app expression says take this crap and apply these values to it. Okay, so the problem's right here. It's just badly written code. Well, I was using it as an example. All right, so.
My snoring distracted him.
No, I rewrote this weeks ago, or at least last week. All right, so there's the lambda that we're applying to everything in this list. The issue here is that this guy right here isn't producing for us. Oh, it's over here to the right, isn't it? That guy isn't what we think it is. We want that guy to be the list containing these two things. That's what we want it to be. So in the context of this whole thing, we have an app expression. This stuff lives inside of so that's the car. Oh, wait. Can't we just do this? That's the list containing the parameters. The CDDR of LCE. If LCE looks like this, the car of that guy is this. So the cooter car of that guy is that. So the cooter of that guy would be the list containing. So it's just 1D. So I need to extend my environment with these parameters. These are the parameters, and these are the values for those parameters. And those values, currently, this is one value, this is the second value. We want to get a list of those values, so that's the cooter of LCE. Oh, we took that out. I didn't fix it. Okay. Cooter of LCE. What's that? There's that. Oh, like that. Like that. That's if we do the if. Otherwise, do that. Our worlds are ending.
I think the red text is getting bigger.
It appears like more is getting wrong the more we try to fix it. Like, oh.
Here, I want to go back to what we had. I'm going to put that back because I want to look at this piece right here. All right, so if I'm in this code right here, I guess I'll just comment this out for right now. It feels wrong, but whatever. I just want to see what LCE looks like right here. Well, actually, what I want to see is not LC directly. I want to see this guy. That should be the guy starting with a lambda. Well, that is a lambda, so I actually just want to see this. Give me bucket 1 of that guy, which is this. So then bucket 2 of that guy okay. So if I do CDR of LCE, that gives me the list containing our lambda expression, that guy. I just want one thing printed out here. CD. Ah, that's what I want. CDDR. That looks like the values we want to map across, right?
Let's try that. Sounds legit.
No, I tried CDR. That's what they all say.
You forgot the D.
So what you're saying is you want the D.
All right, so this is mapping this guy across
At the same time.
that.
2 D's right in the middle.
Oh, hold on. I still have my last closing guy. There we go.
Still not. Also measures your strokes per minute. And distance of stroke. Distance of stroke.
Was that parsed correctly? All right, so now we have the right list. So we're good there. Let me just print out CDDR LCE again. So here is a list containing that. So if I map,
Shouldn't that outside list, the very first one, shouldn't that be, say, app expression?
no. Because I'm trying to map this guy, this function right here, across this list.
Oh, okay.
Because I'm extending my environment here.
Yeah, okay. What's the parsing?
All right, let's just leave it in this state right here. We'll look at it when we come back. It's got to be maybe a bug at our extend-env for Lambda. No,
I don't see what can really bug in there.
this is not mapping correctly across that.
We're almost there.
What?
Here, I can do this. Map lambda x across this guy. That should just print out the individual pieces.
I just sent you a really short Onion article.
Okay.
You should look. Did you read it?